Hello friends. In the previous video, we discussed the basic operators in Python, part 1. Now, let's continue with part 2. The next topic is membership operators. Membership operators check whether a value exists inside a collection, such as a string, list, tuple, or range. There are two types of membership operators. The first one is the in operator. First, let's understand what the in operator does. The in operator checks whether a value exists in a sequence. If the value exists, Python returns true. Otherwise, it returns false. Let's take an example. Create a list called fruits and add the following elements: apple, banana, and mango. Now print apple in fruits. Let's see a real-time example. If apple is inside the list, the answer is true. Otherwise, the answer is false. Run the code. The output is true. This is how the in operator checks whether a value exists inside a sequence. The second one is the not in operator. The not in operator checks whether a value does not exist in a sequence. If the value is not present, Python returns true. If the value exists in the sequence, Python returns false. Let's use the same example. Replace apple with orange. Now the code becomes print orange not in fruits. Let's see a real-time example. Run the code. The output is true, because orange is not present in the fruits list. The not in operator returns true when the value is not found in the sequence. If you replace orange with apple, the output will be false, because apple already exists in the list. This is how the not in operator checks whether a value is not present in a sequence. The next topic is bitwise operators in Python. Imagine your computer only understands two numbers, 0 and 1. Everything inside a computer, photos, videos, games, and even Python programs is stored using binary numbers, zeros and ones. So how does Python perform operations directly on these binary numbers? It uses bitwise operators. Bitwise operators work directly on binary numbers, bits. A bit is the smallest unit of data in a computer. A bit can have only two values, 0 or 1. Before learning bitwise operators, let's first understand binary numbers. For example, decimal number 10, binary number 1010. When you use bitwise operators, Python first converts decimal numbers into binary. Then it performs the bitwise operation on those binary values. This is why understanding binary numbers is important before learning bitwise operators. The first one is the bitwise AND operator. The bitwise AND operator returns 1 only when both bits are 1. Otherwise, it returns 0. Let's take an example to understand this. Suppose A equals 10, B equals 12. Now, print A and B. Before performing the operation, Python converts both numbers into binary. The binary representation of 10 is 1010. The binary representation of 12 is 1100. Now Python compares both binary values bit by bit using the AND operator. The resulting binary number is 1000. Python then converts this binary number back into a decimal number. The decimal value of 1000 is 8. Now, let's see a real-time example. Run the code. The output is 8. This is how the bitwise AND operator works in Python. The next one is the Bitwise OR operator. The Bitwise OR operator returns 1 if at least one of the two bits is 1. Let's use the same example. Suppose A equals 10, B equals 12. Now, print AB. Before performing the operation, Python converts both numbers into binary. The binary representation of 10 is 1010. The binary representation of 12 is 1100. Now Python compares both binary values bit by bit using the OR operator. The resulting binary number is 1110. Python then converts this binary number back into a decimal number. The decimal value of 1110 is 14. Now, let's take a real-time example. Run the code. The output is 14. This is how the Bitwise OR operator works in Python. The next one is the Bitwise XOR operator. The Bitwise XOR operator returns 1 only when the two bits are different. If both bits are the same, it returns 0. Let's use the same example. Suppose A equals 10, B equals 12. Now print A to the power of B. Before performing the operation, Python converts both numbers into binary. The binary representation of 10 is 1010. The binary representation of 12 is 1100. Now Python compares both binary values bit by bit using the XOR operator. The resulting binary number is 0110. Python then converts this binary number back into a decimal number. The decimal value of 0110 is 6. Now, let's take a real-time example. Run the code. The output is 6. This is how the Bitwise XOR operator works in Python. The next one is the Bitwise NOT operator. The Bitwise NOT operator flips every bit. In other words, a 1 becomes 0, and a 0 becomes 1. Let's take an example. Print (10). Before performing the operation, Python converts 10 into its binary representation and then flips all the bits. The output is -11. Why is the result -11? In Python, integers are stored using a method called 2's complement. Because of this, flipping all the bits of a positive number usually produces a negative number. For beginners, you only need to remember one simple rule. The tilde operator flips all the bits, which often results in a negative number. Now, let's take a real-time example. Run the following code. Print (10). The output is -11. This is how the Bitwise NOT operator works in Python. The next one is the left shift operator. The left shift operator moves all the bits to the left. Every left shift multiplies the number by 2. Let's take an example. Print 5 left shift 1. The output is 10. This means that 5 left shift 1 is the same as multiplying 5 by 2. 5 times 2 is equal to 10. Let's look at another example. Here, 5 left shift 2 means multiplying 5 by 2 means 5 times 2 times 2 is equal to 20. Now let's take one more example. Here, 5 left shift 3 means multiplying 5 by 2 3 times. 5 times 2 times 2 times 2 is equal to 40. In simple words, every time you shift left by 1, the value becomes 2 times larger. Now, let's take a real-time example. Run the code. The output is 10. Now change the code to print 5 left shift 2. Run it again. The output is 20. Next, change the code to print 5 left shift 3. Run it once more. The output is 40. This is how the left shift operator works in Python. The next one is the right shift operator. The right shift operator moves all the bits to the right. Every right shift divides the number by 2, discarding any remainder. Let's take an example. Print 20 right shift 3. The output is 2. What does 20 right shift 3 mean? It means the number 20 is divided by 2, 3 times. First shift. 20 divided by 2 is equal to 10. Second shift. 10 divided by 2 is equal to 5. Third shift. 5 divided by 2 is equal to 2.5. Since the right shift operator discards the fractional part, 2.5 becomes 2. So, the final output is 2. Now, let's take a real-time example. Run the code. Print 20 right shift 3. The output is 2. Remember, every time you shift right by 1, the value is divided by 2, and any remainder or decimal part is discarded. Note, 20 divided by 8 is equal to 2.5, but the right shift operator discards the fractional part, so the final result is 2. This is how the right shift operator works in Python. The next topic is operator precedence in Python. Operator precedence is the priority order that Python follows when an expression contains multiple operators. Instead of evaluating operators randomly, Python follows a fixed order of precedence. Without these rules, Python wouldn't know which operation to perform first. Let's consider this expression. Print 10 plus 5 into 2. Should Python evaluate it like this? First, 10 plus 5 is equal to 15. Then, 15 into 2 is equal to 30. Or should it evaluate it like this? First, 5 into 2 is equal to 10. Then, 10 plus 10 is equal to 20. To remove this confusion, Python always follows its precedence rules. Now, look at this Python operator precedence table. This table shows the priority of Python operators, from highest to lowest. Pause the video and take a screenshot. This table will be very useful while writing Python programs. Now, let's take an example. Print 10 plus 5 into 2. According to the precedence table, multiplication has a higher priority than addition. So, Python performs the multiplication first. 5 into 2 is equal to 10. Then, 10 plus 10 is equal to 20. Therefore, the final output is 20. Now, let's take another example. Print 10 plus 5 into 2. According to the precedence table, parentheses have the highest priority. So, Python first evaluates the expression inside the parentheses. 10 plus 5 is equal to 15. Then Python performs the multiplication. 15 into 2 is equal to 30. Therefore, the final output is 30. This is how operator precedence determines the order in which Python evaluates expressions. Now, let's take a real-time example. Run the following code. Print 10 plus 5 into 2. The output is 20. Because the multiplication operator has a higher priority than the addition operator, Python first calculates. Now, add parentheses to the expression. Print 10 plus 5 into 2. Run the code again. This time, the output is 30. Because parentheses have the highest priority, Python first calculates. This example shows how operator precedence changes the order of execution and produces different results. Thank you for watching this video. Please like, share, and if you have any doubts, leave them in the comment section. Do subscribe for more updates.